Okay. Yesterday we discussed about the traditional approach and how it is working and what is the source and what is the ETL process and how the data will be loaded into a data warehousing system or database system. From there, how we are processing. We have discussed about it. And when the data grows it and what are the limitations we may face with the traditional approach. We have seen those limitations like cost, and we have seen about the time consuming process, and why it is time consuming process we have seen. And because there is no distributed no there is no data distribution, there is no parallel process, and there is no data locality, and there is no fault tolerant, there is no replica, and so on. We have seen a set of limitations in a traditional approach. And the that is a problem statement, and we have seen the who causing the problem. And it means we have discussed about a big data as well, and what is a big data and classifications, and we have seen characteristics we have seen. Not we didn't see about the classification. We will see classification today. And we started discussing about what is a Hadoop, and what is a file system, what is a distributed file system, and what is a Hadoop file system. We are going to see what is a Hadoop distributed file system. And also we have discussed about a definition of the Hadoop, and we have seen like what is the Hadoop and what are the components are there in Hadoop. And and we discussed like to create a Hadoop distributed file system, how many machines it's required, and all we have discussed in the last session. So continuation to that, the Hadoop distributed file system, so we are going to see in detail now. And once we complete this Hadoop distributed file system, then we will be seeing architecture and we'll be seeing internals of Hadoop distributed file system. Okay, let's look at guys here. Okay, so as we discussed yesterday, a Hadoop distributed file system is a special kind of file system where it will store a huge amount of the data. And how it will store the huge amount of the data we're going to see now. To create that file system, so all the file systems are virtual, as I told you guys before. To store a large amount of the data, it means to create this kind of file system, what we need to do, we need to install a Hadoop software, right? When we install a Hadoop software, internally what it does, and before after installation we have to do some configurations, so using those configurations, your Hadoop file system, how it will create and what is the what is the functionalities of the Hadoop file system, we're going to see now. So Hadoop distributed file system, to create a Hadoop distributed file system, we need a two type of machines. One is the name node, other one is the data node. And the data node is the place where the actual data will be stored, and the name node is the place where only the metadata information will be stored, right? Now let's look at guys how it's no the data will be loaded into Hadoop file system. When I want to load a data, how it will work, we are going to see that now. Yeah, let's see in this architecture, try to understand a little bit more. We'll be having something called gateway node or edge node or client machine who will interact with the name node, because the name node is the master and the name node is the a point of contact. Even though you can talk to our data nodes, okay, it doesn't mean that we cannot talk to the data node, we cannot log into the data node. Why? Because in the environment you will be having all the machines IP addresses and their port numbers. So you, when you know the IP address and port number, and when you know the password of no username password for the specific machine, obviously you can go ahead and connect to the data nodes, right? So you can directly connect to the data nodes. But when you directly connect to the data node, you you cannot, that will not work as a Hadoop way. That will work as a normal way. Let's say I want to connect to your machine, I can log into your machine directly. I can check what is I mean, if I have permissions, I'm talking about. I can say if I want to install some software, or if I want to run, if I want to run some services, or if I want to do something, I can do it. But that operations are it is performing on the local file system. That is actually not doing in the Hadoop file system, right? To do on Hadoop file system, we have to go through a proper channel. It's called proper protocol. That is, we need to talk to the we need to talk to the master. From the master, if you want to know about your data where and all it is stored, take the copy. I mean, take the metadata information from the name node and go ahead and search in that. Go ahead and connect to the data nodes and search it. So that's what it will happen. Let's see how it will work actually. And the master is nothing but a name node here. He is the person who manages the whole cluster, and he is the single point of failure. If master is not there, there is no point of having so many data nodes. Even you cannot even you cannot do anything. But that problem has been solved with the different approaches. We will see that the name node is mainly meant for storing the metadata information, taking the requests and respond to the clients. And data nodes are meant for store the actual data in the form of blocks and communicating with the name node, saying that every 3 seconds it will be sending the heartbeat, and every 10 seconds it will be sending the block report also. Report what are the blocks are there in the data node. Okay, that information also will be tell to the name node. Okay, let's look at here. That is the architecture we need. Yeah, go ahead.
we, why we can't directly access the name node? Why the client is gateway is needed for that?
Okay, so being a developer, it doesn't mean that you cannot access the name node. You can access, but in the production and the development environment, you will not be they will not be given you details, or they will not given you access to directly access to the name node. They will not give any access. So there may be a chance you can directly access the name node. We may corrupt it, right? So if whenever we want to launch a job, or whenever we want to do something with a Hadoop cluster, you will be having a gateway node. Actually, the gateway node also another mission where the Hadoop already installed in it. Being a developer, or being a tester, or being a someone else, if you start down directly accessing the name node, there may be a chances where you can corrupt it, because name node is a crucial device. If that is goes down, there may be a chances of your work may stop, or your business may halt, because it means it cannot be it will not take any request, it will not respond to anyone. There are chances.
Okay, so it means client as gateway will contain the copy of the name node
No, no, no. It
and the
is not.
same
It is
information.
not. It is not copy. Okay, it is a procedure. When you submit a job, or when you are executing any command from the edge node, or a gateway node, or a client, the procedure is. I mean, you're not still seeing the commands. That's the reason. We have seen this doubt. So when you execute that into the client, what will happen? The client will interact with a name node, because whatever the jobs you are writing, or whatever the commands you are writing, that has to execute on the Hadoop cluster. To execute on the Hadoop cluster, we have to execute from the client. The client will talk to the name node. We can access. Okay, it doesn't mean that we cannot access the name node, but you will not be having a permissions. The Hadoop administrator, or whoever, what they will do, they will not give a permissions to talk to a name node. They will not give you your name, they will not add you into the group policy, name node group policy. Understand?
Yeah, so
Yeah.
Ravi, so gateway is not a part of the cluster, right? So it will be outside the
No,
cluster,
it is a part of the
isn't it?
cluster only. It is a part of the cluster only. I mean, part of the cluster means what you called I mean, it's a very straight, simple, right? Suppose I want to talk to you. How I'm talking to you? I'm talking through a phone, or I'm talking through some other channel, right? Since you are in a different location, or since you are a crucial part, let's assume that I should I don't have permissions to talk to you directly, but I can talk to you through a phone, or through something else. that through, I mean, that channel is your gateway.
Yeah, it is that I understood. It is as simple as like a SQL client, where using SQL client, we're accessing SQL server
Hmm.
and running the queries and all. So SQL client need not be in the server. So in the same way, what I'm understanding is gateway also need not be in the same cluster. It can be outside the cluster also.
It see okay. Your point is that it not part. It is a see. It is the part of the Hadoop only. It is a part of the Hadoop cluster. Okay. What I'm trying to say here,
Mm-hmm.
it is a part of the Hadoop cluster. One second. I'm just clearing this. It is a part of the Hadoop cluster. It will your gateway node will be configured every time whenever you create a Hadoop cluster. And you can also directly talk to the name node. You can also submit a jobs. Why they will not give you direct access? The only reason is the name node is a crucial part. The gateway node also countable node in the Hadoop cluster.
Mm-hmm. Okay.
Understand?
Yeah. Thanks. Yeah.
Any other questions, guys? There is a one second, guys. Just because I need a little space in the top. That's the reason I'm taking this. Okay. 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 Charlie has some question. I think he has raised in the chat window. Let me talk. Well, let me see what is the question. What he has raised. Let me read out the query. So all the users accounts will be maintained at the name node or before name node. Again, any middle layer of the checking the user's authentication. Oh, okay. See, Chari here, your name node will not maintain the all the users accounts and all. There will be some policies. There will be less who are all can access. They'll give you permissions. Okay. Let me put into a very simple way. Suppose if you want to access my machine, I cannot give you access to you. I cannot give. So it means your Linux machines or Linux servers, whatever the servers you talk, whatever the gateway you talk here, you will be having something called the users or permissions related stuff, where in that stuff we have to maintain the user information there, username. We have to mention the username in that. Okay. So when you mention the username there, let me show you what's the username. Let me show you what's the username. What is this? Yeah, look at here. This is the data node 1, right? This is my username. This is my username. Okay, so if I want to access any cluster or any other machine, the Linux administrator will be maintaining some information, some group policies. Okay, so in that group policy, your username has to be added. If they add your username in that group policies, it means you are eligible for accessing that name node or whatever it is, right? So it doesn't mean that he is this your name node is maintaining your user details, right? That's group policy is maintaining the details. The group policy will be having your they will give you permission whether you are able to access it or not. That's it. That's simple it is. A clear, Chari? And let me see what else the questions. And yeah, it's your system admin will take care of it, correct? Okay. Yeah, let's move on, guys. Okay, let's see now how the data will store into the Hadoop cluster and we have seen how the data will store into the normal file system. Now let's see how the data will be loaded into Hadoop cluster and what is the benefits of it. We'll see that. Now I have a file. Now I have a file which is called amazon.log file. Now I have a file called amazon.log file. This file I want to store into Hadoop cluster. Okay. So to store that, we will write some query, or I can say some command, some Linux command. The Linux command is Hadoop fs, or okay, there are two different ways we can execute the command. Source, from where it is, and destination. This is the command we'll execute. This is the command we will execute to store the data. Okay, this is the command, or we will execute this. Okay, we'll talk about the commands, really not to worry about these things. As soon as you execute these commands, what will happen? Where will execute this command? We will execute in our gateway. We will execute in our gateway machine. Here, the client machine will execute the command. What your client will do, first will check whether the the source is available or not. The source is available or not. The source is exist or not. Let's look at, guys. I'm just executing. I already have a Hadoop installed in my machine. I'm going to execute a small command. Let's see that. You can use the Hadoop fs or hdfs dfs. Okay, Hadoop fs minus put, okay, slash Ravi. I'm just giving wrong, okay, wrong path dot txt. Okay, this I need to put into Hadoop. Let's say somewhere. Even you can just say slash. Even you can just say slash. It will go there. Okay. Now, as soon as I press the command, it is internally checking. First, it will go and check whether the source is available or not. Then, if the source is available, it will take and put into HDFS, right? If the source is not available, look at here, slash Ravi kumar.txt is not available. It's not a file or directory. It means it does not exist. No such file or directory. What it is trying to do here, your client, first it will check whether the path is available or not. If the path is available, the given path is available, your client job is to divide this log file into blocks. Divide this file into blocks. It means it will it will break. Even we have seen, as I told you before, any file system will do the same way. Okay, they will divide into the blocks. Okay, they'll break internally, and so on. Let's assume that this is 1 GB file. Whenever you install Hadoop has a default configurations, guys. Default properties are there. What are they? I can say, I want to say configurations. Default behaviors. The default behaviors are, there is something called block size. There is something called block size. This is by default 128 if you are using Hadoop 2. So these days everyone is using Hadoop 2 only. So no one is using Hadoop 1. Okay. And there is something called replication. How many duplicate copies you want, how many duplicate copies how many copies you want to maintain in the different locations. That's called replication. Okay, so these are, let's assume that for time being there are so many configurations are available. For time being, let's talk about these two. So when it is dividing a file, it will calculate, okay, I need to divide the 1 GB file or 10 GB file or 1 TB file into these many blocks. How it will calculate? 1 GB means 1024 by 128 MBs, right? Both are MBs. Okay, so both are MBs. So you can divide this. It comes to close to 7 point something. It means 8 it will come. Okay, so what it will do, it will start divide your blocks and it will give the names for it. Block 1, block 2, and so on. Block 8, and so on. Block 8. I will show you that, guys, how the blocks will looks. Okay, I'll also show that how the blocks will look, where the blocks will be there. After dividing this, your client client will talk to the name node. Your client will talk to the name node saying that, hey master, someone asked me to put the data into your cluster. I need a path, like a destination. This destination is there, no? So I need a machines to store the data. So we have given a destination path here. Let me take a different color, guys. Okay. I need this destination path. Let's assume that this destination is slash data slash landing, or whatever it is, whatever you can write, slash some date wise you are storing. Let's assume that 030917. Here you are loading the data. Okay, so this is my destination path. Okay, this is my destination path. Your it lost the name nodes saying that I want to store the data in this path, and I need a missions information where I can store it. What are the missions I can store it? In the cluster, you will be having so many missions, no? Which mission I can make use for the storing the data? Now, your name node responsibility is your name node. What it will do? Your name node, guys. Look at here. Your name node. Your name node. It will first has to do some pre-checks. What is the pre-checks? The pre-checks are whoever connected to the name node. The user will be there, no? User from even from the client, he's trying to connect to the name node. The user is authorized. Is the user is authorized, it will check. And the next one is the location, the destination is already exist. Is the destination exist? First one is authorized, the destination is not exist. It means your user should be authorized to access. Okay, first condition, user should be authorized to access. The second one is the destination path, whatever the path already he has mentioned there, it should not exist. Because if the path is already exists, it will tell that the path is already exists, correct? So path should not be exist. The path should not be exist. If these two conditions are success, your name node will check for the missions. Your name node will check for the missions, where and all the missions are available. Because how many missions I want? Replication is 3. I need a 3 missions. And it will tell to the client, yes, okay, I'm able to do that. You can send me the data. It will tell to, after checking the user and destination, your name node will respond to the client saying that, hey, you can send the data now, he is fine. Okay, you can. Then your client, what it will do, it will take the first block, guys, not the whole file. This is the major difference. Try to understand. It will take the first piece of the data. The data has been broken into chunks, right? It is divided into chunks, right? It will take the first chunk, very first chunk, b1, and go to the name node. Hey master, now it will tell to the master so many details. Hey master, the file name is Amazon. The file name is Amazon, and path also. This is the chunk I brought. Okay, this is the chunk I brought, and the chunk size is 128 MB. Correct, right? The block size 128 MB. It has been divided, no? The chunk size is 128 MB, and the chunk has to be stored into 3 copies. Has to be stored into 3 missions. Give me 3 missions. Now your name would look for the 3 people. It is similar like any new task came into the project. Okay, and the client, what he will do? Hey manager, this is the work I got. Okay, this work, to finish this work, I needed 3 people. You give me 3 people. Then what manager will do? He will refer his Excel sheet. Who are all free? Who are all who all can work on this task? Because your manager will be knowing that who is and what their skill set, correct? The name node here also will maintain the such kind of meta information saying that how many data nodes are there, what are the data is stored in that machines, and what they're currently running, are they free, are they busy, such kind of information will be there with the name node. The name node, what it will do, it will select a few guys from the cluster. Similarly, our manager will select 2 3 people from the team, right? So based on the skill set, based on the availability, based on the so many things. Okay, and he will respond to the client. Similarly here, your name node also chooses three missions. Your name node also chooses three missions. Why three missions? The replication factor is 3. The replication factor is 3. So let's assume that he has chosen three missions. Okay. Let me remove this command part. It's really not required at this.
So Ravi, so who decides how many replications need to be done? The user or the Hadoop system decides how?
Yeah, it's okay. Here I have one more question to you. The user means, in your terminology, user means who's? A business user or a developer or who? In this here, user means who? User means who?
Did you get my question? Did you hear my question?
Yeah, I understand your question. Your question
Oh,
was,
okay, okay. I thought I was on mute. Oh, okay. As long as you have heard it.
okay. The question I understand the question. Who decides the how many copies I want? Correct. That's your question. Very simple way. Correct.
Right, right, right. I
So
thought I was thinking that it is up to the Hadoop system, but you said the user is deciding.
no, I
So,
mean not user is deciding. Okay. I mean
okay.
in this your point of view, user means who?
User means who I'm trying to save the log file
A
in
developer,
Hadoop system.
loading the data.
Right.
Who's loading the data? Okay.
Mhm,
We
mhm.
will not, being a developer, we will not decide it. And there will be
Yeah.
architects, there will be architects, or there will be, no, there are business users, and there will be people who decides saying that I want this data is a crucial, and this data has to be at any cost. It has to be available at any point of time. Even though complete cluster goes down, also my data should be available. Such kind of statements will given by your client or your architect. I mean, who actually takes the business decisions, correct? Based on that,
Uh,
we will configure it. Configuration is done by user only. We will configure it. We will modify the files. Okay.
mhm, 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 mhm.
So
Okay, got it.
first,
Thank you.
yeah. The decide number of copies is how many number of copies are required. It will be decided by architect or upper layer on top of the architect. Being a developers, we will not decide how many copies. We can suggest. Okay. I see that this data is critical. I see, because I see that there are so many operations that we are doing on this data, and I feel this is the base data, or I feel this data is more important. Why can't we go with multiple copies? We can suggest it, but the decision will be taken by our architect on the upper layer. Once they say that yes, this many copies I want, or once they say that at any cost my data should be available or my data should not be lost, then we will do the change. I mean, being a developer, that is our task, no? So we have to change it. Where we will change, there will be some XML files. As soon as you install a Hadoop software, it will give some XML files, and you will go ahead and change there. Okay. You can also suggest decision will be taken by someone, but change by done by you. It can be 2 copies, it can be 3 copies, it can be 4 copies, whatever the number of copies is decided by the use case. Decided, I mean, depends on the use case, depends on the data. So we can do that. Chari has some question here in the chat window. Let me talk this. So based on the our replication factor, name node will direct to the destination nodes. Her client is not bothering about on what nodes I need to copy. The same path will be exactly available on based on the replication factor. Hope I am on track. Does client will get the acknowledgement for the, yeah, I mean, Achari, I'm going to explain that. Okay, your question, your doubt will be get clarified in a few minutes. And if out of three only 2 copies are success, then user, this is also, a little advanced question I'm going to explain now. Hey, I one copy failed etc. Hope everyone get the my question. Yeah, I understand. Chari question is that, the Chari question is that, uh, while loading the data, I'm telling that 3 copies. I store only 2 copies. What will happen? That is a failure case. We will also talk about that. Nothing will happen. I'll also tell you that. That's that thing. Other one is, will everyone will get acknowledgement. That also I'll explain that, Shari. Okay, I'm going to explain that. Actually, it is a little early. Okay, and sub should not changing the configuration settings be done by administrator, as administrator knows well about the infrastructure. What if we need to update the file, then path will be the same, so how will be loading the file? Okay, so here sub question is that, is the change, the replication factor change is going to do a developer or administrator? The nice question. If you have a permissions, even developer can do that. Most of the cases, the administration will not give a permissions. Administration only will take care of it. Yes, as you said, administrator will have a more control on the infrastructure. Administrator only will do a change. If you have a permissions, let's assume that in my case, I have all root permissions, except in a whole my team, I only have all the root permissions. I have a permissions to my root, my Solar. I have a permissions to my UAT cluster. I have permissions to my dev. I have permissions to my production. I have a permissions to all clusters, because I mean there will be few guys who can handle all the requests, right? So in my team I have all the permissions, so I can do a change. Similarly, you are a developer. If you have a permissions to do it, you can go ahead and do it. If you do not have a permissions, you cannot do it. But ideally, these changes will be done by the administrator. So I hope I answered your question. Coming to the Sandeep Sharma, what we need to do, what we need to update a file, then the path will be the same on how, okay, how will loading will fail. I'll be explaining that, Sandeep and Srushti. SRC file divided into different blocks. Who's take care of these things, and who decides how many blocks is required? Okay, Srushti, it's a very simple question. I mean, what I'm trying to say here, your source, let's say it's 1 GB, your block size is also decided by, as I told you, infrastructure team, or I can say uh, uh, the block size and all. We can also check the performance. Even your administrator can change it, the value. The block size is just a value, we need to change it. By default it is 128 MB. You can go ahead and make it 256, or you can go ahead and make it over 512, whatever the change you want. No, our configuration file is not the source. The source is nothing but a data where it resides. The source data, which is not, the data is in another server, not into Hadoop. That is the source. Now, how many copies? Yeah, block size will be there in the source, correct. Block size will be in the configuration, correct. So, how many blocks? It's easy. File size by file size by block size. Then number of blocks automatically will comes. It's no one with no need to decide by someone. It is a file size by what is your block size. It's automatically calculates. It's just a calculation. Okay, yeah, so we're actually getting diverted. Let me continue this. Okay, now your client came and talked to the name node master. He master decided to give three missions, and he has given mission 1, and he has given mission 3, he has given mission 5. Guys, to choose this also, he has some policies. He has some our name node has some policies. That's called, I'll write it here, but we'll talk about that later. Block placement policy. And there is something called rack awareness. There is something called rack awareness. Keeping this in mind, your name node will choose the missions. Keeping in this mind, it will choose the missions. How it will choose, what is the rack and all, we'll talk on later. So if I start bringing everything into a plate, it's very difficult to understand what to eat. If you have 100 items in front of you, you really get confused to eat what, right? So let's go one by one. So we'll talk about the policies later. For time being, you understand your name node takes three missions randomly. Okay, your name node takes three missions randomly. It has taken 135. This is not always fixed, it will take 135. I'm choosing 135 to make you, explanations will be very easy. If I say 123, everyone think that it will take in sequence. No, it is not actually. Okay, so now it will give the node information. Node information is nothing but IP addresses. That IP addresses will given to a client. 1, 3, 5. It will be in a sorting order. Sorting order. which IP address has to come first, which IP address has to go next, which IP address has to go next. It will give in a sorting order. The sorting order is nothing but how far this machine is there from the client, how far these machines are there in the client, right? How it is decided? The network distance. The network distance from the client to data node, what is the distance? So from the client to this data node, what is the distance? From the client to this data node, what is the distance? Based on the distance, it will identify. So the first one is very near to the client, second is near, third is near. It means third is next nearest. It means 1 3. It will not give 1 5. Why? Because 5 is too far. It will give 1 3 5. Then based on the network distance, it will give a nearest machines first. Okay. Now once your client receives the IP addresses, once the client receives the IP addresses from the name node, your client will connect to the first machine, nearest machine. The client connects to the nearest machine first. The client connects to the nearest machine first. After that, this machine, but anyway, these all machines are internally already connected, guys. These machines internally already connected. These your data nodes already internally connected. I'll show you the diagram. Your name, your machine one is already connected. The pipeline will be get created. The data pipeline will be get created. This is the data pipeline. The data pipeline will be get created. Okay, this is the pipeline. Okay, the flow, the pipeline. Now what your client will do, once this connection is, once it is established, the connection, once it establishes the data pipeline, a data stream pipeline, I can say, what your client will do, it has a 128 MB chunk, right? That's a very big chunk to send it through a network. If you see, 120 MB cannot be sent in a single attempt. It will break into chunks, packets. Do you guys remember, anyone heard about the packets? Packet 1, packet 2, packet 3. The whole data will be divided into packets. The packets will be passed. The first packet will come to the name node, data node 1. The first packet will come to the data node 1. The same packet will send to a name data node 3. The same packet will send to data node 5. The packets will come. The packets, not the whole block. Packet will come, first packet. And the packet know the pack, I mean, if anyone knows the how the data will transfer through a network, the data will be transferred through a network in the packets only, small piece of the data. The packet size is 64 KB. Okay, so now the packet will come. So once the packet is reached first one, successfully it is stored, the same copy will send to the 3, the 3 will send to the same copy to the 5. And once it is once 5 receives the successfully, let's assume that once 5 receives the successfully, the 5 will send acknowledgement to 3, 3 will send the acknowledgement to 1, 1 will send acknowledgement to client saying that, hey, we restored, you send me the next packet. Like this they will keep sending the packets. Once they store the block successfully, let's assume that he stored the block, and he stored the block, and he stored the block. Once the blocks are successfully stored, the pipeline will be deleted, pipeline will be removed, and these machines will inform to the name node saying that, hey name node, we stored the block 1 which is belong to Amazon, and 3 also tell I store the block which is belong to 3, 5 also will tell I store the block which is belong to Amazon. So block 1 has been stored into machine 1, machine 3, machine 5. Okay, the next attempt it will take the block 2. Next attempt it will take the block 2. Now the block 2 will start. Block 2, the machines will be different in this query. Okay, now next task. The first task, I have chosen people has manager has chosen 3 people. In this task he may choose the different people, correct? So now this time let's assume that he has chosen 3 4 6, and block 3 this time he can choose 1 2 3. Block 4 this time he has chosen 1 3 5. It's possible, right? So what we are trying to expand here, your data nodes make sure that they will store always unique blocks. Unique blocks means block 1 is there. Okay, block 1 cannot store in the same machine again. It will not store, it will never store. There is no point to store the same block in the same machine. Why you are storing into different machines? For the fault tolerant, for the backup in case of failure. If you store both the blocks in one machine, if it goes down, there is no point of storing both the blocks in one location, right? It will not store. That will make sure that this is successful scenario. Chari, I'll come to you. Okay, I remember a question, failure scenario. Once they're all successfully stored, once they all successfully stored, the pipeline will be deleted. Okay, the pipeline will be deleted. Your name node will maintain this information. Your name node maintain this information. This is called metadata information. This is not actual data, right? This is not actual data, right? This is just a metadata information. Amazon file, how many blocks, and those blocks where and all they resides, and so on. Okay, this first information I'm making I'll writing here. This is called file to block mapping. File to block mapping. The file has been divided into these many blocks. And the below one, this is called block to data node mapping. Block to data node mapping. Block to data node mapping. Okay, you can look at the file has file to blocks, block to data node. This is called file to block and block to data node. So now your name node maintains the metadata information. The data is stored successfully. Happily it is done. I'll come to a failure case, Chari. Give me a few seconds of time. Okay, few minutes of time.
We have one query. Sorry, disturb.
Yeah, go ahead, no problem.
Actually, can we say, suppose if my file is divided into 10 blocks, can we say for each block, client will communicate with the name node to get the address of the block,
Exactly.
address of the node, data node?
Every block, 10 attempts it will do.
Okay, understand.
But you really not see this. Okay, let me show you an example here. You really not see this.
Because for us, we just execute the command,
Exactly.
but internet will.
That's what internally. That's what I'm trying to say. It's internally does this. Let's assume that I'm trying to do this. Okay, I'm trying to do this. Oh, okay. This is my path. This is my path. In this case, when you press enter, you never really realize it is happening. You never see this. Okay, it is an internal process. What I have explained, internal process. The command is success. The command is success. Okay, you can see whether the test is there or not. You can use Hadoop FS or Hadoop HDFS DFS. Okay. See, the data is available. It means the data is stored successfully. Okay, so you never see this. Okay, what I'm trying to say here, this process will happen internally. You never see this. For you, it's a file. That's it. For you, it is a file. It is a destination. That's it. What it has happened internally, you really never mind. But why I'm explaining this? This is way internet works. Sub, it is possible. Okay, it is possible. Overwrite is possible. It means that it will existing data it will be replaced with a new data in the same path. Okay, it is possible. We will talk about that. That's not recommended, but it is possible. We can do with a force. Okay, see, let me show you now itself. I'm executing the same command one more time. Same command. Same, already data is loaded. The data is destination is already available. Destination is already available. Look at here what it is telling. The slash, I mean, the destination exists. The file is already there. What is the point to put it? But you can load it. Still, you can load it. Okay. It doesn't mean that you cannot make, you cannot do. Still, you can load it. But you have to make use of the force. You have to say force. Sorry. Yeah, you have to say. Sorry. What is this? You have to say with the force. You are doing a forcibly. You are doing it forcibly. It is did. It is done. It is success. That is possible, but it's not recommended. I'll come to that point later. Is that clear? So, Sup?
Yeah, Veera. Thanks.
Yeah. Now, this is how the data stored, guys. This is a fully distributed. Now, try to understand. The data is fully distributed. Now, I'll be asking a couple of questions. You try to answer. Everyone, please keep unmute. Please keep unmute, everyone, until unless if you have some background noise. Look at here. Is the whole data stored in a single machine or multiple machines? Whole data, complete Amazon.log. Is it stored one machine or multiple machines?
Multiple machine.
Multiple machines.
Fully distributed. Okay. Let's go back to 1 second. We'll compare. We'll try to solve the limitations. Yeah. Coming to first point, cost. I'm getting echo from someone's who is using the loudspeakers. Please keep yourself on mute, please.
But it is okay, right? We can skip this part, no?
Which part? No, we cannot skip this. This is the comparison, right? With the traditional approach.
Right.
This is
right. So can
yeah.
we not skip this comparison? We understand that Hadoop is doing something which was not available in the legacy system.
Sayed, I understand. You have some experience and you understood, but what about others who are new minds? We need to keep everyone in the mind, right? Yeah. Please just give a few minutes. I'll just try to finish it up. Don't worry. I mean, don't mind, please. Okay.
No. My intent was to cover more ground, so that's okay.
Yeah. So coming to the cost, guys. So here there is so many licenses are involved and so many resources are involved. But when it goes to Hadoop, it's open source, and as we discussed yesterday, it is a commodity hardware, so everyone can afford it. Cost is less compared to traditional approach. The cost is less. You guys agree with me? And since it has a distributed data has been distributed across the multiple machines, while it is processing the data, how the data will be processed? This is now it's the MapReduce comes into picture. Try to understand, guys. Now MapReduce comes into picture. MapReduce also similar way. You will write a job, you will create a jar. I'm keeping very simple way to make you understand. You will submit from the client. You will submit from the client your developer, and you will write a submit query and submit it. It will go to the name node saying that, hey, I need to process this data. Give me some resources, and based on the queue, okay, it will maintain the queue, which job has to execute when and all, and schedule my job and do that. Now name node identifies, oh, he want to process Amazon data. Fine. Amazon data, where and all, which are the machines it has? It has these machines, and it will start launching a job. Okay, and wherever the data is available. Let's look at guys here. So the block 1 is available 1 2 3. I can choose one mission. Let's say I'm choosing third mission. And block 2, where it is there? Oh, I'll choose a block 2 in the second mission. Parallel process. Look at guys here. Block 3 I will launch in 1. Block 4 I will launch in 5. So 4 parallel tasks are how many blocks are there? Oh, those many based on the resources available. So those many parallel tasks will be launched for a job. Parallel tasks. It means block 1 is getting processed here, block 2 is getting processed here, block 3 is getting processed here, block 4 is getting processed here. All after processing each and every piece, it will take some results and it will be consolidated. That is called map and reduce. We will talk about the MapReduce very detailedly later or in some other session. For time being, you just keep in mind this. So the blocks first it will process the map task. The map task is for individual tasks on each and every machine. It will process like parallelly in all the machines. Then it will take the results, it will consolidate. That's called reduce. So it means I have a parallel process. Yes, no, please guys unmute and tell me. That gives me a feeling like you guys are able to follow. Yeah.
So,
Yes.
I'm confused. Sorry.
Yeah,
So
go ahead.
what is the parallel process you're talking about? Is it the jar file or some process, some code that you are sending to each of the data nodes? That is what it is process, parallel
Yes,
process?
each and every, okay, let me put it this way. I want to find a maximum value on the whole data. Okay.
Mm.
Block 1 will have some values, block 2 will have some values, block 3 will have some values, block 4 will have some values. Okay. To find the
Mm-hmm.
maximum, all the blocks has to be processed.
Right.
So, but here the data is distributed across the multiple machines. Each block will be processed individually.
Right.
So based on the data available in the block 1 says that this is the maximum value. Yes or no? Block 1 is
Right.
some piece of data. When I'm launching a job on this max query, let's say I'm just doing a max on this block 1, it says that whatever the data is available, 2, 5, 10, let's assume that. It says the 10 is the maximum in my block. And the similarly block 2 also will do. Similarly block 3 also will do, block 4 also will do. Then I need to take the 10 here, 15 here, 20 here, then I need to do a consolidation. So your data is getting processed parallelly. Yes or no? Ed,
Correct.
the
So
data
you are transporting the logic into each of the data nodes, which
exactly,
you yesterday said data
exactly,
localization.
exactly. I'm transferred my logic to each and every machine, right? So the parallel processing is happening, and the data localization is also there. And because of the parallel process, because of the distribution, because of the data localization, the time consuming is less. It will take less time to process it. And coming to replication, we have automatic replication at the time of whenever you load the data. We have automatic replication. You have automatic replication. We just saw, right? The three copies at maintaining. And coming to auto fault tolerant, look at guys here. I'm processing the block one. The block one is failed. I mean, block one means mission three is failed. Mission three is failed. The same block is available in mission one and mission five. It can launch a job in any one of the mission. It means your job is not failing because of one mission is failed. Yes or no? Your job is not getting failed because of one mission failed. The data is available in other missions. Why can't I make use of the other missions? That is called um, fault tolerant. Correct? We are achieving the fault tolerant also. We are achieving the fault tolerant also. So we have solved all the limitations from the previous approach. That's why Hadoop is better. Is that clear to everyone?
Yeah.
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 Explain data localization once again.
Data localization is nothing
Data
but,
localization.
yeah, I have written my max query. Okay, I have written my max logic. Okay, in my jar file, I have a logic which is a max logic. Now I need to execute the logic in all the machines. So I'm sending my logic to the machines. I mean, I'm sending my logic to the where the data resides. My data resides in these machines. Mission 3, mission 1, 2, 3, 5, like that. Wherever the data resides, I'm sending my data to my logic to there. That is called data localization. Let me. I mean, is that answered your question, Amar? I mean, whoever is asking.
In traditional approach also, the same is happening, right?
So, can you tell me how that same approach is happening in the traditional approach?
Data resides only in one place, right?
I'll show you the Amar. Okay, when I'm
I'll show you the number. Okay, when I'm
whether it's happening in the
whether it's
traditional
happening in
approach
the
also or
traditional
not.
approach or
Okay.
Okay, that I'll show you. That time it will make
Okay.
very much clear. Okay. Any other questions? No. Very good. So coming to the failure scenario. Okay, Chari. Coming to the failure scenario. I said three copies, but it is loaded only two copies. Will the job success or failure?
Oh, Vida.
Yeah, Deepak.
Oh, sorry to interrupt. Actually, I was asking a question regarding the data localization.
Hmm.
I think in existing RDBMS, suppose if you take Oracle,
Hmm.
we also have the data localization Oracle also.
So are you talking about OLTP or OLAP?
Well, OLAP.
OLAP. Can you explain how it is data localization there?
Okay. Not the Oracle, because OLAP are stored in the different database and in the database like DB2. Suppose my database is DB2.
Okay, Deepak, let me put it very simple way to make you understand that. So when you have a huge amount of the data, when we are doing analytics, the data will be resides in one of the data storage. Like that data storage can be any database. It can be Oracle or DB2 or Teradata, whatever it is. The data will be resides in one location. The analytics will locate in different location. When you start your analytics, when you start doing analytics, the data will be transferred through a network to the processing machine. Let's take a simple example. So we have written a web application. Okay, the application will be running on the server, right? A Tomcat server, application, WebSphere or somewhere, right? It will be running on some application, right? So your application required a data. Is it your application code is going to a data, or data is fetching to application? The Deepak and Amar. The data is fetching to the server, right? Where the Tomcat or WebSphere, whatever the server.
Yeah, yes.
So it means we are not have a data localization there, right?
Yes, yes.
Uh,
So sorry, go ahead, Deepak. It is muted. Sorry. Go ahead, Deepak.
yes, actually, I think it's unfortunately it's unmute. Actually, suppose my database is stored somewhere. As
Mm-hmm.
a user, I'm sitting somewhere.
Mm-hmm.
So I query the data. Suppose I'm using the SAS for as a reporting tool to
Mm-hmm.
see the report based on the data which resides somewhere.
Mm-hmm.
I query the data. So my whatever the query to access the DB2, I write the query, and this query will go to the data where the data reside, correct, the server side, and execute there, and the data will transfer from the server to the my machine.
The data getting transferred, right?
Data, yeah, but the query is executing at the server side.
I mean, your server in the sense you're talking about at the data or your SaaS server.
Let's suppose I'm sitting here and my server is somewhere else, where my database server is somewhere else,
Mm-hmm.
and I want to query some data.
Okay, I'll
So
do
I
one.
execute the query.
Deepak, sorry to stop you. I'll do one thing. I'll take this query for after few minutes.
Okay, sure.
We'll talk about that detail later, if you don't mind.
Okay, sure. No, it's okay.
Yeah, because a lot to there to discuss. I'm little concerned about the time. Yeah, thank you. We surely will discuss about this. I'll surely show you the diagram also. We'll surely discuss about this. Okay, data locality. Okay, okay. Look at here. Yeah. Apart from the data locality, does anyone has any other doubt? Okay, let's take a failure scenario, guys. So I supposed to store 3 copies. Supposed to store 3 copies. It is storing only 2 copies. Will the job will success or failure? Is the job will success or failure?
Success.
The job will success. Why? Because it's a duplication, and also your as I said, there are so many other configurations along with your Hadoop configurations, right? Other configuration is it is a replication factor. There is something called minimum replication, that is 1, and there is something called max replication, that is 512. So minimum replication, the meaning of the minimum replication is at least I need to 1 copy has to be stored. At least 1 copy has to be stored. Later I will take care of other replicas. Later, when you will query the health of their cluster, when you query the when we try to check the health of the cluster, when we try to check the how the data is stored in the cluster, we can get other 2 copies from this 1 copy. That can be done. Okay, the minimum configuration says that at least 1 copy should be loaded successfully. That is the meaning of this. Let's assume that you have modified the minimum copies are 3. If it is trying to store only 2 copies, it will fail. The meaning of this minimum is at least 3 copies. I need to maintain minimum 3 copies. So if you are not able to store 3 copies, there is no point of storing any data. So that's the meaning of min replication. So by default, the minimum replication is 1 and the maximum replication is 512. The minimum replication, if you change to 3, if it is trying to store 2 copies, job will fail. Chari, I answered your question. Go ahead, go ahead, Deepak.
Sorry, Veer, actually I was waiting for this question for a long time.
Now go ahead. What is the
Suppose
question?
actually the replication is basically, as you mentioned that my minimum replication is 1. So I'm expecting, suppose in my file there is 10 block. So I'm expecting that each block should be at least one copy should be in the SDFS.
Correct. And one more point,
Correct, na?
Deepak, before going to your question. Suppose, one second, I'm making you mute because I'm getting the echo from your side. So I have of 10 blocks. If it is stored only 9 blocks, the job will not success. Until unless it store all the blocks at least once, then only job will success. All the blocks has to be, that's where we'll get the whole data. Otherwise we'll not get the whole data. We may end up with the wrong results. If I store only 8 blocks, 2 blocks are not stored due to some problem, 2 blocks are not at all stored due to some problem, the job will not be success. Okay, yeah, go ahead, Deepak, with your question.
So sorry, I just want to enhance light this question. As you mentioned, the first example where the block 1 will, after getting the IP address from the name node, the client will transfer the block 1 to the the data in the form of packet from client to data node 1, 3 and 5, correct?
Correct.
So suppose we have a data of 164 MB. So in the dividing the packet, so suppose and it transfer from 1, 3 and 5. Let's suppose, and each will give the you can say acknowledgement to the is a previous data node. Suppose 5 will give the to 3 and 3 will give to 1, correct?
Correct.
And 1 will give to the client that to show that data is already copied properly.
Correct.
Let's suppose if in the first one, suppose the first block it copied to 1, means we have a 1 copy, but while copy to 3 it failed, means we have a minimum replication we required 1. I have a 1 copy, but 3 is failed, so 3 didn't give acknowledgement to the 1, and because of that 1 didn't give acknowledgement to the client. So in this case, is it success or failure?
It is success. So at least 1 copy is there, no?
But the data node 1 didn't inform to the client, because data node 3 didn't inform to the 1 that it's a success, the data is copied.
So data node 1 informs about 3 and 5 along with himself.
Correct. Yeah.
So he will not give the acknowledgement of 3, but he will give acknowledgement of himself and 5. So client knows that the data has been stored.
Okay. So basically 1 will give the acknowledgement to 1 plus the 3 and 5 also.
Exactly.
Okay, understand.
Veera, in the same question, I have one doubt. Will the data node 1 will wait for the acknowledgement from 3? Because if it's giving the acknowledgement of 3 and 5, then he will send the acknowledgement to client only when he will get a acknowledgement for 3. Or you mean to say that he'll send first for his success, then he will receive for 3, then he will simultaneously it will send all together acknowledgement.
Okay, a very nice question, Sandeep. Here, see, who's sending the data to 3? Is the client or data node 1?
Data node 1.
So data node 1 expects the acknowledgement from the data node 3, and certain time it will wait for the certain time. If he is not getting the acknowledgement in the certain time, he will assumes that it is failed, and he will send his responsibility. Like his responsibility is he has to send acknowledgement to client. He will send it. He will not. He will wait for certain time only. Some time will be there, right, for each in the network to get the acknowledgement from the other destination. If he didn't get in that time, he will stop sending the packets to that mission.
Okay. Okay.
Go ahead, Sandeep.
So in that case, so if, for example, data node 1 to 3 and it got failed, so data will not be safe to data node 5 also then?
Could you please repeat your question? There was a disturbance in between.
Sorry, if data node 1 is sending data packets to machine data node 3
Hmm.
and it got failed,
Hmm.
so data node 3 will not send the same packets to machine 5 also. So 5 will not be able to store the data.
Okay. If in case of data node 1 fails, okay, in case of data node 1 fails, data node 3 already received the packet, it will send to the data node 5. So in the next packet, the client directly sends to the 3. Why? Because your client didn't receive the acknowledgement from the data node 1. It is the client assumes that data node 1 is dead. Let's connect to data node 3 because your client already remember what are the IP addresses he got from the name node. It will cache that information into the client. The client will connect to the data node 3 directly and it will send the on the rest of the packets to data node 3 and 5.
No, what I mean to say is that client send the data to data node 1, it got success. Then data node 1 will send to data node 3.
Hmm.
Suppose that fails.
Hmm.
So now the further sequence from data node 3 to data node 5 will happen or not?
Now data node 1, data node 3, data node 1 will send to the data node 5. It's your data node 1 knows that whether it's a data went to the data node 3 or not,
Okay.
right? If it is not went, if it's due to some failure, data node 1 will connect to the data node 5. They all will be having they all will cache you the IP addresses 135. All the data nodes will be knowing them.
Okay. Okay.
Yeah.
Ravi, I have a couple of questions.
Go ahead, sure.
Should I go ahead?
Yeah.
So as you know, like name node actually checks the heartbeat of each and every data node. So here, why actually data node 1 has to talk to data node 3 and then data node 5? Why can't name node directly talk? And anyways, it has to talk, right? Because otherwise, because it is the job of name node to check the heartbeat of each and every node. So name node is also connecting to data node 3 and name node is also directly connecting to data node 5 to check the heartbeats.
Okay. So who actually receiving the data? Data node 1, or I mean whoever the near, right? And who has to transfer the data? See, if you say in that manner, once the data node 1 receives the data node 1 has to send the data to data name node has to send to 135, correct? But do you feel it's a lengthy process or not? And
can't name node at one shot send to data node 1, 3 and 5 directly?
No.
Once it decides that okay, these are the replication factor, these are the nodes where the replication will be.
That is not the job of name node. Name node is here single point of failure. He has a job. He has some other jobs to do. He has in the Hadoop cluster, the name node is the, I can say, it has so many responsibilities. It has to monitor the cluster. It has to monitor the jobs. It has to identify the resources. It has to launch the jobs, and so there are so many responsibilities are there in the name node, right? We cannot keep every responsibility on the name node itself. So you are thinking only copying in your in point of view. So there will be hundreds of people who can connect to the same cluster, right? So that is really not the responsibility of the name node.
Okay, so now once name node comes to know, like, okay, he's not getting any heartbeat for data node 3. So will it be going back and checking which data is getting replicated in data node 3 and it will be taking immediate action for that?
No. He will just mark it that data node is down. And your data node, your client knows that if any of the acknowledgement didn't come from any of the machines, and it knows that it will tell to the other nodes to okay, you ignore it, don't try to connect him again. So you ignore it and you can go ahead and connect to other machine.
Okay, the second question is like, as you said, like there is a minimum replication factor is 1 and the maximum is 512. But every time we are saying replication factor is 3. So what exactly is the ideal replication factor here? When we should choose, because it's like 1 to 512, there are so many numbers. but why you are sticking just for 3? Why it cannot be 5 or 7 or 10 or any number?
That's a very good question. It has a separate video already there in my YouTube, and there's a separate, when I was explaining the rack awareness, so that question will be answered. So actually, that's the question is raised by myself, and I have answered to that. So why it is 3? Why can't it go for 4? Why can't it go for 2? Why can't it go for 5? Why they have taken 3? So to understand that, we need to understand the rack awareness. So that we will talk later.
Okay.
Okay.
Thanks. Thanks.
Any other questions, guys? It's good. I mean, I'm getting a lot of questions. It means a lot of people are, are keen interested on this. I hope I have answered all the chat questions. If anyone, if I missed any question, Sandeep was asked, what if we need to update a file? Then path will same or how it loading? Okay, update file means what do you mean by update, Sandeep? Are you going to update a single row, or you want to or just adding the data?
Just adding the data, because if
That
the
can be
file exists and you said the path
yeah
will be, the path should be unique.
no,
So
that can be done by using append to file. So as soon as a client, your name node knows that it is a append to file path. I mean, let me show you here. As soon as your name node knows that this command is to append to a file, then it will allow the file, the data the path should be exist, right? Suppose I'm telling that there is already a path, you need to append to that. It means the path already should exist, right?
okay,
So in that case, no doubt, no problem at all.
okay. Because the first time you said that a path should not exist.
That is for put command. That is for putting the data. This is the different command I'm going to show you now.
Okay,
This is a different request, right?
okay, I got it.
This is a different request. Append to file. This obviously this file should be exist. This path should be exist in this case.
Mhm.
If I give something which does not exist, there is no point, right? What do append? So in this case, it is
So
created.
we,
Hmm. Go ahead, sir.
yeah, from
Srishti.
developer perspective, like where the data is going actually in which data node.
Which data node it will go, we never predict it, but the data will go to see. Yeah, I see that a lot of questions come from this internal process, but at the end we only worry about where the data stores. Look at here, if I want to get the data, if I want to do a cat command, did the cat command on block wise, or did a command on the file wise? At the end, for the developer, the path is more important. That's it, the path, nothing else. This path, developer always sees this. We never sees that whether inside how many blocks are there, whether the block is loaded into this machine or this machine. We never look at that. We look at only the path, at the destination path. The destination path, we need to keep in mind only destination path. We really not required to understand about whether the blocks are loaded or not. We really know it. As soon as I'm giving this path, I'm getting the data or not. Process also. Cat is nothing but a kind of a processing. Suppose you are doing something. When you are processing your data, you will just give a path. We never talk. We never talk the block level. We always talk a file level. Is that clear, Srushti? Why I'm showing
Yes,
this?
Veera.
Why I'm showing this? We should understand the internal architecture, how it is processing. That is the reason I am explaining, as personally. I mean, we really not to worry about it, whether how many blocks are, why it is chosen 135, why can't it go to something else. That's not really no matter to us. Is that clear?
No,
Any doubt?
I mean from developer perspective.
Yeah, from the developer perspective also, we really not to worry. See, you don't have a control on See, you really don't have a control on saying that, oh, hey, don't go to 135. I don't like 135. You take a 246. I like only even numbers. That kind of control is not there. If you have that kind of control, yes, we can do something with being a developer. Block level, we really not have any control. The block level, the name node, I mean, the architecture decides this. Block level, we really not have any control on. If you take any distribution, you take Hortonworks, you take Cloudera, you take Amazons, you take IBMs, you take Microsoft, any Hadoop you take, any company's Hadoop you take, we really don't have a control on the block level. But we can understand that this is how internally it stores. Is that clear, Srishti?
Yes, Vida.
Any other doubts, guys?
So you were showing this example on the Linux machine. Can this be also done on a Windows machine by any chance?
Yeah, the Hadoop 2
Hadoop?
Hadoop 2 is started supporting Windows as well, but you need to install some Sigwin, some WinUtils. There are so many things. And yes, there is a way to do in Windows, but with all the developments and all the productions and all the environments will be in the Linux only.
No, for learning purpose, do I have to have a Linux machine in
Exactly.
order to learn?
You
I
should
know it is better to do that way, but suppose I do not have a Linux machine. So
so
can I learn
if
on
we
the
do not
Windows?
if we do not have a Linux, what we need to do, we need to go for the virtual box like this. We need to install some software virtual box. In that we need to install Linux. If you really want to, since we have a less RAM, let's assume that I don't have RAM, I have only 2 GB RAM. The alternate way, I can go with a dual boot. I don't want to go dual boot. I want to work on Windows only. For that, what we need to do, there is a way to do it. Okay, I'll tell you that, but that's internal way. I think most of the guys won't do this. What you need to do, you have to go to a source code. You have to download the source code. After downloading the source code you have to build with the Windows utils. So by default it will be given for Linux environment. So what we need to do, we need to build ourselves for Windows environment. Then we need to take that and we need to put into Windows, and then we need to make work out it. I have done it sometime before. I think 2-3 years before. I really didn't remember now how to do it. If anyone interested in that part, please let me know. I can do that. I can get you back. Okay, is it
Okay,
clear?
thank you.
Yeah.
Yes.
Any doubts so far? Charlie, I understand on the 5 minutes break, but we are running out of time. We have hardly another 30 minutes, but we have a lot to discuss. What we can do, we can extend to next weekend somehow something. And if you guys really looking for a break, 5 minutes break, or go ahead and come back. Else, please continue. So whatever you guys say it. I'm pretty comfortable to continue. No problem with me.
Yeah, let us continue because we have less time and we can continue on the next week also. My opinion.
Chari and others.
Yeah, unless somebody needs a bathroom break.
Yeah, that's true. It's a morning and the obvious. It's a nature. It's natural. There is if min and max is 3, and then if only 2 copies. Okay, I might have already answered. Simple. You are saying copies are 3. Okay, yeah. I think you must say min is 3 and max is then it's ensure all 3 copies. Okay. Yeah, correct. I think I have covered all these questions, Chari. Yeah. Continue. Hey, everyone is more interested now. Okay, let's continue, guys. Some more words for continuation. Yeah, so I'll give you that no video. Not to worry, I'll give that. Okay. This is how the architecture works. Okay, so this is how the more uh, uh, what you say, the Hadoop versus traditional approach. And here we have so many limitations. Can anyone tell me what is the limitations we see here? What is the limitations here?
Single point.
Single point of
Single point
failure.
of
Single
failure.
point of failure. Name node is a single point of view.
If name node goes down, whole my cluster will goes down, right? So that can be achieved by I mean there are different what to say architecture changes that came into picture after this architecture change. So let me show you that.
So can we have two name nodes
I'm
and
coming.
replicate them?
I'm coming to your little early. Yes, we'll come to that point. Yes, that is not only the responsibility of the name node. Okay, so there are something else as well. So let's see how it will work.
Can I ask you a dumb question?
No.
Can the data nodes be in different geographical locations, just to prevent them from failures together? So, a natural calamity happens in New York City, so you have another data node in Houston. So, New York node is down, so you can run your business from the other nodes. Can that happen?
Not the data node, okay. So you can have, but again, it's a bad design, right?
Okay.
So the problem is the whole cluster will be in the same location. But I understand
Uh,
there is something called disaster recovery, DR. We'll
mhm,
call DR. Same
mhm.
replicated cluster will you can have another location, another geographical location. What we will do will periodically we will take the data from this location and we'll put into other data I mean also disaster recovery location. But keeping one data node in New York, one data node in India, one data node in Japan, I don't think it's really it is not
Yeah,
at all meaningful, I hope. I mean you
yeah. The
understand the
network.
network bandwidth and network distance, you understand,
Yeah, yeah.
right?
Since
But I see that disaster recovery sizes as multiple clusters. One cluster I have seen in UK and one cluster I have seen in Singapore. I have seen one cluster in India. I mean, it depends on the
right.
geographical. So they will.
Yeah, makes sense.
So what they will do, they will identify the natural disasters, how where is very less and on which area and which state, and they'll identify that and they'll do it. Okay, so coming to the single point of failure, that is not only the limitation, there are some other limitations. Actually, the name node will do the so many responsibilities. Let me put that into first, and if time permits, we'll also see the architecture changes. Uh, even I can share that. Even I can share that other videos. I mean, even you can find that architecture changes videos in my playlist where it is clearly detailed explained about them. But now I just want to explain the internals of the name node. This is more important part. How name node stores the metadata. How name node. What is the roles and responsibility of the name node? So whenever let me make a name node here. Let me create a name node. Since I'm talking about the name node, I'm drawing only name node here. Okay, I'm not drawing about the data nodes. I really not required at this point of time. Okay, look at guys here. This is my name node. This is my name node. Name node. So what name node? How the metadata will be stored in the name node? What? How the metadata will be stored in the name node? Is that just stores or is there something else? Yes, there is something else. Okay. Let's look at guys here. Whenever we are trying to do a transactions, whenever the transaction is nothing but you're putting the data, getting the data, deleting it. These are all we call as a transaction. Deleting, update, appending, remove or modifying, or creating a directory, creating a file, such kind of operations. Whatever the operations, submitting a job, whatever the operations you do, we'll call them as a transactions. Whenever do a transactions, the transaction will go to a name node only. The request will go to the name node. Whenever the transaction comes to the name node, whenever the transaction comes to the name node has to respond to the transaction, respond to respond to that the request, right? So whenever your name node is working, this all the information will be available in the RAM. Yes or no, guys? Let's assume that you have taken your mobile and you are started playing with your games. Where the temporary data will be stored? In the RAM only. Yes or no? Let's assume that you are playing a game in your
Yes.
mobile. You are across the level 1, level 2, level 3. So this level information, where it will be there? It will be there in the RAM. Similarly here, when the name node is running and when the name node is started doing so many transactions, all the transaction detail information, the metadata information will be there in the RAM. Will be there in the RAM. Correct? And if the name node restarted, I mean name node is shut down and restarted, so will it back the same data back, or it will go, I mean, how it is?
We will lose that RAM
Right?
memory.
Yeah. 1 second, guys. I'm just getting a call. Okay, just get disconnected. So whenever you're doing a transaction, it will keep in mind. Okay, this block is here. This block is here. This is the data, and this is Amazon data. This is in this location eBay data. In this location Facebook data. Some details will be maintained in the RAM. Correct? At the time of it when it is running, but when it is restarted, it lost all the contacts. But the RAM will be cleaned up. Yes or no? And after restarting, I send a request, hey, get me the Amazon data. It cannot able to find the Amazon data because it's not there in his RAM, right? To get to the Amazon data, it has to do some other process or some other file. It has to look into some other hard disk or permanent copy to get it. Yes or no?
Yes.
So at the time of your name node is running, all the information, all the metadata information will be there in the RAM. Okay, but the problem is when it restarts, the RAM will be cleaned up. It will lose the contact with the locations where it will lose the metadata information. So to avoid that, the name node has a local storage, persistent storage, that's called permanent storage in the hard disk. So your name node has a permanent storage. That permanent storage will be there in the form of files. In the form of files. That file will call edit log or log file. Some people call log file, some people call transaction log, some people call edits. So many names, different names. For our convenience, we'll keep edit file. And there is something called one more file called fsimage. fsimage. Okay, one is edit file, other one is fsimage. These two files will be there in the hard disk of the name node, local hard disk of the name node, or I can say local file system. In the local file system, whenever you do a transaction, the transaction will be go through a RAM. That information will be there in the RAM. The same information will be right into the edit file, the log file. If let me put in a very simple example. Let's assume that you have logged into Facebook. Let's assume that, let's take a e-commerce application. You have logged into Amazon. As soon as you log into Amazon, the Amazon will maintain internally a log file. Yes or no? This is the user, this is the location, this is the browser he has used, this is the product he has seen. All the information will go into the logs. Yes, no?
Correct.
Similarly here also, it will also maintains the log information internally in the logs file. That log file is nothing but your edit file. What information will be there in the edit file? Transaction information. What is the transaction ID? Who did the transaction? What is the permissions of the transaction? What is the permissions of the transaction? And which operation type, what operation he has done. That information will be there in the edit log file. Okay, and it will be the FSMS will not come into picture at this point of time. Okay, you will be keep doing a transaction. You have keep doing the transactions, and RAM will, anyway the RAM has an information, and your edit file will keep putting into that information in this. Okay, this is one of the responsibility, guys. As soon as your name node restart, the first responsibility is it has to read the edit log, read the edit log, read the edit log from the edit.
So why would you restart your name node in the middle of things?
I didn't restart, Syed. It may go, power may fluctuate or power may get restart or something may happen to it can restart.
Okay. 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 Yeah, sure. Agree.
So that's the reason I'm trying to say. So we may need to restart sometimes because some service is not coming up, until the service will not come up until unless you do a restart. There are such kind of scenarios, right?
Right, right.
So when it restart the name node, what will happen? First, it will go and talk to edit. Talk to means it will read the edit file, which is there in a hard disk, which is there in a hard disk of name node, hard disk of the name node, and it knows that it maintains all the transaction information, guys. Okay, before getting into this, let me show you how it looks. Then you can visualize it. That's the reason I'm going to show you. You can imagine. The imagination will help you to understand more. It's loading because it has quite a large amount of the data. Look at, guys, here these are all edit files for each and every transaction. What are the transaction you have done? I have created sometime before, I have appended sometime before. That information also will be there in this. Look at here's edit file. It maintains the transaction information. Okay, look at here, edit underscore in progress. This is my in progress edit file. These are all old edit files. This is current in progress edit file. Okay, if I restart my machine, or if some other configurations are there, we'll talk about that later. For time being, you just assume that only when you restart, then only it will create a new edit file. It's not always restart is required. There are other configurations. Even without restart also, the new edit file will be created. The old edit file will be closed, and new edit file will be created. That we'll talk later. So look at, guys, here the edit files has some number and in between hyphen, right? What is this edit files? This edit file saying that this is my starting transaction ID and this is my ending transaction ID in that edit file. Look at here, 18417 18418, the starting transaction ID and ending transaction ID. In this in progress also, you can see this is my starting transaction ID 18433. Once it is closed, I mean once it is when it restarted, it will close this. Not only restart, guys, that's what I'm trying to say. There are some other configurations, or you can also execute a command manually. Being an administration can do that, everyone cannot do. And he can execute a command to save the metadata, or he can execute the rolling the edits. He has some commands. When he did that, this in progress edit will be closed and the new edit file will be created. So you guys see this, the file is in the binary format, you cannot really read it. Okay, the edit file has the starting transaction ID, ending transaction ID. Inside that, it will contain some transaction information. Is that clear? And FS image is also there. You can see here only two FS images, only two FS images, only two FS images, but so many edit files. Why? There is a reason behind it. We will explain that in detail later point of time. That is also configurable. You can change it. You want 10 images files, you can give a 10 as a number there. Okay, that's why that's what I'm trying to say. Hadoop is so many configurations you can do. You can play with your configurations. You can achieve the better performance or better, what you call better access to your cluster. Now this
So
edit.
as a Hadoop developer, in a day-to-day his activity,
Mhm.
as a Hadoop developer, does the developer have to care about these edit files,
No,
or this is internal to the Hadoop system, and we can safely,
no.
the developer can safely ignore how it does, and
He can safely ignore it. The simple answer, he can
yeah,
ignore it.
yeah, it
The
makes sense.
day-to-day life activities of the developer is like just developing his code, or this is fixing his code. Either it can be Java, or it can be Scala, it can be something else, or SQL. He just
Mhm.
has to go ahead and fix it. How we work in the normal environment or normal projects, the similar way he is. But when we say Hadoop, everyone thinks that something we need to do with the machines. A developer, nothing to do with the machines. He just go ahead and write his codes and fix the bugs, and he test it with the cluster. That's there. He'll go on launch and he'll test it, and he'll find if he finds some bugs, and he'll just do it. Configuration changes, edit, doing something here and there, nothing done by developer. This all has a special team for that, a supporting team or administration team. They will take care of it. Okay.
Right, thanks. That makes sense.
Okay, so when it restarts, what it will do, it will go and read your edit file, and edit file contains the transactions information, and from edit file the FS image will be created. It is some process style, we'll call it a journaling, or some process it's called checkpointing. Some people call checkpointing and all. So what it will do, from edit file, in the edit file will have raw data. I can put in this way to make you understand. Your edit file will contain the raw data, but FS image contain, FS means file system image, it contains what is the file, what is the block, what is the user, what is the size of the block, how many blocks are there. That information will be there in the FS image. FS image is the more accurate data, more accurate information about, or more precise, or more clear information about your file system. Oh, file one, oh, test one we have just loaded, test.csv. Oh, test.csv, who created? Hadoop data node 1 user. Oh, and what is the size of the block? 120. Oh, how many blocks are there? 10 blocks. Oh, what is the size of each block? This. All this information will be there in the FS image. Okay, and it will read the edit file, it will process the edit file, it will create FS image. It will create in the sense it will merge with FS image. We'll call merging process. Everyone will call it a merging process, guys. You guys also can make use of the terminology called merging process. So it will read the edits and it will merge with FS image. After merging the FS image, the merged FS image will be loaded into the RAM, because your RAM should know what is the up-to-date file system information. It will be loaded back to the RAM. Now your RAM is loaded with the whole information. Someone can come and ask Amazon data. Someone can come and ask eBay data. It can give, because it's up-to-date information is there. So while doing this merge process, your name node will be in the safe mode. The safe mode is nothing but read only mode. It means it cannot take any request for writing the data into the Hadoop. It will give the request for the reading whatever the data is already exist. It is a read only. Okay, so this safe mode is merging process. And also when we'll come out from the safe mode, once the merge process is completed, once the data nodes also has to send some block report. Okay, the minimal block report to the name node. Once they send the minimal block report to the name node, it will come out from the safe mode. Safe mode is a different topic. We'll talk more detail about the safe mode later point of time, guys. These are all the responsibility of the name node. When it start, it has to merge from edits with FS image. The FS image has to load into the RAM to understand in the detail, and your name node will at the time of merging, the name node will be in the safe mode, and at the time of what you call to come out from the safe mode, it has to send the minimal block report, and the merging process has to complete. And when it in safe mode, it's just like read only mode. Okay, so that is one of the responsibility of the name node. Now see, in this merge process, let's assume that there may be a possibility, not that single point of failure is one of the limitation. And if I didn't restart my cluster for 3 months, my edit log will be very much bigger one, right? It will be huge. The edit log will be huge if I didn't do a restart for 3 months. There are so many lakhs of requests are coming to the cluster. There is a possibility of my edit log will be bigger one. Yes or no? Obviously, right?
Correct.
The edit log will become huge. When edit log become huge, the next start, it has to merge with FS image. Let's assume that it's become 1 GB. Merging 1 GB data with FS image will take so much of time. Until it finish the merging process, it will not come out from the safe mode. It cannot take any new request for the writing the data. Correct? So that's also one of the limitation. And I didn't restart my cluster for some long time, and completely dead. My machine is dead. Not restart, just dead. There may be a possibility of losing the data. I mean, we have so many recovery tools. Even yesterday also I have done some recovery from the deleted data. If its recovery is possible, fine, well and good. If the recovery is not possible, there is a possibility of the data loss. Yes or no?
Right.
These are all the limitations: single point of failure, data loss, your restart time may take longer. No, if you didn't restart your cluster for the name node functionality. name node restarting time may take longer if it is a huge edit file. These are all the limitations. To avoid this limitation, they have done some architectural changes. I hope everyone understand the edits and fs image. They are metadata files. They will be there in the name node local file system. And the limitations are, let me make a note of the limitations of it. Single point of failure. SPOF. Single point of failure. If it is failed, we cannot access the cluster. And the data loss, there is a possibility data loss. And third one is like restart time may take longer. Restart time may longer in case of you didn't restart your cluster or name node for longer. And if edit on fs image is huge. And these are the limitations of the name node. All right. So how to avoid these limitations? One second, guys. Here there is a question from chat window. The question is, how often name node goes into a safe mode? Will client we wait every time name node goes into the safe mode? It is not very often, Saurabh, Sub. That's there where we have a different kind of architecture change. The evaluation of the architecture. There are different change for the architecture. Now it is not very often. I see very rarely. Sometimes whenever it is uh, name node is restarted, or sometimes the data is not well balanced. We'll talk about those things, those scenarios later. That's the reason I said the safe mode itself is a separate topic. Okay. And how to avoid these limitations? We need to do some architectural changes. And what Hadoop did, the community did. So along with an existing name node, they brought one more name node. This is the name node. They brought one more name node called secondary name node. The first one is a name node, primary name node. You can call as a primary name node. One second. This is the primary name node, and the second one is the secondary name node. The secondary name node responsibilities, while I'm bringing this machine into the architecture, while I'm bringing this machine into the cluster, I'll do some special configurations for this. The special configurations are the responsibilities or roles of the secondary name node is every 1 hour, he has to go to a name node. Take the edit. Every 1 hour he has to merge edit with the fs image. Edits with the fs image. Because to reduce the burden on the name node. Every 1 hour or whenever it reaches to 1 million transactions. That is the primary responsibilities of the name node. Merging. Okay, merging is the primary responsibility of the name node. How it will work? Try to understand, guys. How it will work? Your name node, as I told, name node maintains. Let me take a different color here to explain. Let's take let's assume that I have started my cluster at 8 o'clock. Okay, today. So at you started your cluster, it will create edit file. It will create edit file. Your name node will have edit file and fs image, no?
Correct.
It will have edit file and it will have fs image. Let's say both files are empty because it's a fresh cluster. And you started doing a transaction at 8 o'clock, and it means that fs image, your edit log will get filled with some data. Every 1 hour I said 9 o'clock, 9 it is reached. Your name node say secondary name node says, hey name node, give me your edit file and fs image. I have a responsibility of the merging them. As soon as the request comes from the secondary name node, your secondary name node, your name node will not make use of the old edit. It will create a new edit file. It will create a new edit file. The edit file is given to this. It means what I'm trying to say here, as soon as your name node is given edit file, the old edit file to the secondary name node, the primary name node will not make use of the existing edit file. It will create a new edit file for the new transactions. So it will start merging here. It will create, it will merge it, it will make it updated fs image. Updated fs image. Then this guy will have these are all internals, guys. We're really not going to do anything. So but to make you understand, I'm explaining these things. You don't take very seriously it is, but you understand this how it work internally. This is that is important with respect to interview perspective or with respect to our knowledge. So we'll started doing a transaction 9 o'clock and all those things, and it is reached at 10 o'clock. And again there will be a request will come from the name secondary name node. Hey, give me that edit file. It will take the edit file. It's not required fs image. Fs image is already there in this secondary name node. It will merge with these two and it will create updated fs image. And as soon as it's given at the 10 o'clock, it will create a new edit file, and it started doing the transaction. At a 10:45, the name node is restarted. At a 10:45, the name node restarted. As soon as the name node restarted, what is the responsibility of the name node? When its name node restarted, what is the responsibility of the name node? It has to read the edits. So whatever it has, the 45 minutes of edits, 45 minutes of transactions. It has to read this 45 minutes transactions from the edit file, and it has to merge with whom? It has to merge with whom?
FS secondary.
Yes. Where is fs image is there? Fs image is the name node, secondary name node. It has to ask the fs image. It will take the fs image from the secondary name node and it will merge it. It will make it the updated fs image. Now look at here, the name node, we have reduced the burden on the name node. Instead of merging from 8 o'clock, we are just merging last 45 minutes. Yes or no? And the restart time is little quicker. Restart time is little quicker or not? Compared to the previous. And now, let's assume that in this case, it's completely dead. So how much data we may lose?
45 minutes.
Last 45 minutes only. We will not be losing whole data because I have a backup. Since the data is storing into the data nodes, even if data name node goes down, I have a data is available in the name nodes, data nodes. By using this metadata information, I can recover it, right? I can access it. So that's a we are solving. We're not completely solving, but we are reducing the impact with the secondary name node, right? We are reducing the impact with the secondary name. Either it can be every 1 hour or it can be every 1 million transactions. Is that clear? We are reduce the impact, but still the limitations are available. And also, as per the name, your secondary name node is acting as a secondary. If in this case name node goes down, it will not take any request. It will not, if you send any request for the accessing the data, it will not give because the name node is not available. But secondary name node is there. You may say the secondary name node is there. Why can't secondary name node can respond to the client request? It cannot. It is not meant for that. But why they have named it as a secondary? That's a poorly named. They realized it. Actually, the secondary name node is not acting as a secondary. Whenever you say secondary, what does it mean? The secondary meaning primary is not available. We'll make use of the secondary. But here, when the primary goes down, the secondary is not taking any requests. The secondary is not responding to the client requests. But they says that no, that machine is not meant for that purpose. For that purpose, there is something else, right? You guys able to follow what I'm trying to say? Guys, don't wait till end to ask the questions. Please ask me the questions whenever you get.
The secondary is acting like a DR for an end.
Exactly, correct. But it's not exact DR because DR will have a complete data. But here will not be having complete data. Last 1 hour only it will be having the data.
Correct.
Hourly basis or 1 million transactions. This also can be configured, guys. This information also can be configured. 3600 seconds or something will be configured. You can change it. Okay. Now,
Yeah, yeah, Veera.
sorry guys, there was a flower fluctuation. Flower is gone. Hello, are you guys able to hear me?
Yeah.
Go ahead. Go ahead with your question.
Yeah, so my question was like, secondary is not responsible to check the heartbeats of the data node.
No,
Is
no,
that so, or is it?
no.
Okay. So now if a data node goes down or is dead, probably like when the name node is also dead,
Mm.
then that information exactly when that data node went down is lost. So nowhere it is getting stored.
So we really not require that information, right?
Okay.
So are we
Okay. So
we're not dealing with that information. We are dealing with only data in that mission. Anyway, that data they already replicated in other mission. Whenever that mission comes up or whenever the name node comes up, I can get the data from other mission.
mhm. Okay, but administrator may need no. I mean, when this node went down, so like that's what I was wondering. Like then he,
Mails will be triggered to him.
okay, thanks.
Yeah. Any others doubts? Any other questions? See, we'll be having UI also for this cluster. Okay, Ambari, Cloudera Manager. There are different no services based on the distribution we're using. They can have a look there. It will shows that how many machines are running, how many machines are down. When you click on that number, what are the machines are down, what are the machines are, even you can see here as well. Okay, but it's not a time to show you. That's the reason I didn't really show you this. 196, yeah, 192. Here, this is the Hadoop view accessing your UI. Once you set up done, you can access this UI by using the local host. Why I'm using 128, 192 because the services are running in the Linux. I'm accessing this into Windows. That's the reason I have given IP address port number. Okay. You can also see the information here. How many live nodes? How many dead nodes? And when you click on that link, it will show you that what are the machines are dead. You understand, right? So
Yeah, yeah, yeah.
right, so
Yes.
this can be this can be easily to get. So live nodes, you can click on that, you can see the live nodes, how many live nodes, how many are failed, how many are down. Okay. Yeah, what we are discussing about this. Yeah, let's go out. Any other question? Let's move on. Okay, still limitations are there. The limitations are not yet completely solved, but we just reduce the impact on this impact of that. So the secondary name node has been renamed to checkpoint node. It has been renamed to checkpoint node. Okay, the same functionality, everything is same. The only functionality they have changed is, as soon as same functionality, everything is same. As soon as the merge is completed, they'll upload back the fs image back to the name node. Fs image will be back uploaded back to the name node. Fs image will be uploaded back to the name node, because when it restart, you really no need to give a request for the secondary name node to get the fs image. Your name node can get the edit and fs image from here itself, from his local itself. That they changed the name, they changed the name checkpoint, because actually it is doing a checkpointing. and they have made it as a checkpoint node. See why I'm showing these differences, guys. In interview, people may ask you what is a checkpoint node, what is a data, or what is a secondary name node, what is the difference between these two. Such kind of questions may come raised by them, so we should answer it. That's the reason I'm doing the differences. So there is no specialty of the checkpoint node. Everything is same. Only upload back. It's uploading the your FSMS updated up to date FSMS to the name node. Only that change is made. That is a checkpoint node. Okay, so still the limitations are there. How the limitations has been solved? The limitations has been solved by using, there is another architecture change came into picture, that is called 1 second, guys. I'm just connecting to my actual internet. It's not at up. Fine, no problem. So the other limitation, other change has been made. The change is other architecture. There is something called backup node. They brought a new machine instead of checkpoint node. The new machine works like this. These are all architecture changes, guys. They're all architecture changes. They brought a new machine. The new machine called backup node. Let me. This is name node. This is the backup node. Instead of checkpoint node or instead of name node, it's the same machine only. They just change the configurations, nothing else. Okay. It doesn't mean that they sold out the old machine, they brought the new machine. Okay, the old machine only they can make use as a backup node. The functionality change in the different Hadoop versions. Someone also asked me what is the difference between the Hadoop 1 and Hadoop 2. Secondary name node concept was there in Hadoop 1. Checkpoint node, backup node, and all from the Hadoop 2. These concepts are all from Hadoop 2. Okay, here this name node RAM and this name node RAM will be keep syncing. Whatever you do transaction with the name node, the same information will be here. Then what this guy will do? This guy will take edits and FSMS. He will be merging it. Anyway, he will be giving upload back. The feature is already there in the older version. Your primary name node also will be knowing that updated FSMS and edits. Okay, whatever the transaction you do with the name node, the same transaction will be reflecting into the backup node, and the backup node will be doing the merging process. So there is no data loss here. There is no data loss. Even the restore time also very much quicker, right? So up to date FSMS, up to date information is there here. There is no merging process done by name node, and there is no data loss also. Why? Because whole metadata information is available in the backup node on the fly. As soon as you do a transaction with the name node, the same information is reflecting on the backup node. But it has to be, the configuration has to be little configuration of the name node, secondary name node should be the similar kind of thing. And whatever the configurations you do for the path of the name node, like where your backup has to be there, the same okay, let me put it this way. The configurations, not hardware configuration, Hadoop configuration here and here should be same regarding the name node. Okay, here also the data nodes are not communicating with the backup node. Here also the data nodes are not communicating with the backup node. Okay, only the backup node is acting as a backup to the name node, as an assistant. Clear? Any doubt? I know that I'm going a little fast. The same architecture change information you can find in the YouTube channel. I'll show you the links. Any doubt? Any doubt?
Can a name node can have one checkpoint node and another backup node? Because that is making sense to me.
Can you tell me why should I have both when a backup node is doing the same? In what sense? I mean, I'm trying to understand what is your intention. Okay, why we need checkpoint and backup node both?
There is some difference between checkpoint node and backup node, right? It is just not different names for the same thing, right? There is
what is the sum? Your backup node is doing the same functionality as a checkpoint.
Okay.
It is doing a merging. It is giving updated FSMS to node. Both the RAMs are in sync. There is no data loss. Even if name node completely dead, the same information is available in the backup node. I can take it from there.
Okay.
I mean,
Okay. If they are just two different names, then okay. Then there
exactly,
is no point of.
exactly. Any other doubts? Any other doubt? Any question? Okay, still we have a limitation here. Can anyone identify what is the limitation? If name node goes down here, can you access your data?
No.
It means highly availability is not available. There is no high availability. Right? If one name node goes down, there should be another name node who can give me a response. That is called Hadoop high availability. That's called high availability. Okay, Hadoop high availability, and there are two more topics or two more architecture changes. That is called. Let me write it here. The people may ask in an interview. That's called HDFS HEA high availability, and there is something called HDFS federation. Okay, these two we will discuss either next week if time permits, or you can have a look of these two on my YouTube channel. Okay, so you guys can go through this week. I mean, I just want to where you can get that information? Go to the playlist. This is the playlist CCA 175. Actually, I started CCA 175 the free sessions sometime before. Due to time constraint, I was not able to continue that. Here you have complete details. You can find the names. Sub, you asked me why 3 or 2 or something, right? You can have a look of this video. Sub,
Okay.
are you there with me? Yeah, you can do this. And
Right.
the federation, yes, you can look at here. And backup and high availability, please have a look on this. So you can also have a sequence numbers here: 1 2 3 4 5 5.1 6 7 and all. There is no 5.2. Okay, 5.1 only. You can see all these numbers in sequence. You can complete all of them. You can go through this playlist. It has the same explanation, same detail has been mentioned here. If you want to understand the high availability and all those things. And also I have explained something called differences between, I think okay, I may not explain in this. I just want you to go through this playlist. It will get you a more information about high availability and federation. Okay. Any doubts? It's a 9:10. I'm getting late to the next session.
A small question. So you are trying to explain to us about the architecture of Hadoop system.
Correct.
So if the interview is about a Hadoop developer, will they be asking a developer questions on the architecture?
Yeah, we should have an idea about what they are exactly.
Okay.
We may not able to do, we are not going to do configurations and all. He may say that, hey, you got a chance to do it. Okay, you have option to do it. Will you? And do you know actually, see, these are all architecture. Either developer or administrator, we should know architecture, right? We should know architecture. Whether you are working on it or not, that's secondary. Whether you have experience on that is secondary, but we should know the architecture of it.
Okay, agree.
Yeah, Veera, in fact, like I thought of requesting you, like, because like every time you're saying a developer, so I would also like to know what an architect should do. So probably in next session, so whenever you feel like, okay, that should be told, like,
Yes,
this is what architect should do.
yes, I'll do.
You can go ahead. Yeah,
Yeah.
thanks, Veera.
Veera, how about the Spark? Will you continue the next week, or will you share any link on Spark? Yeah. Chari, yes. I'll plan it, and I'll get back to you. You can get in touch with. I think my WhatsApp is not working because that's configured another machine. What other mobile? You can contact me, or you can send me a WhatsApp message. I'll keep post you guys. Whoever is interested on that, I'll be keep updating you guys in that area. So I'll get it ready. My mobile is reachable now. The calls are reachable now. In the partition level, each partition, what's happening in the memory level, what's happening. We are going to see that in very detail. Uh, when is the next class? Tomorrow? Or yeah, we can. Srishti, to answer your question, we have a regular batch. We have a regular batch which is running morning 7:30 to 8:30. Interested guys can continue in that, or you guys can uh, 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 can wait for the next batch when I'm going to start for a weekend or something. I don't think it. I may start very soon. It may take so much of time.
So is there the next demonstration class? Is it going to happen next week, or
I'll
should
let
we call you and find out?
I'll let you know that, Syed. I really don't know from where you got this information, from which group. If it is on which group or some Facebook or something, I will be updating again the same way, same manner. Or you guys can get in touch with me. I don't have any problem. Okay, you guys can call me anytime. You guys can, you get clarified your doubts if you have any.
Thank you.
Any doubts, guys?
Your way of teaching is very good.
Thank you.
Your patience is very nice, and your interaction is very good. My opinion.
Thank you so much for that.
Same here, Nataraj.
Yeah, we all agree to this, Veera. Thank you.
Yeah, thank you, guys. Thanks a lot for your feedback. Please let me know something I need to improve. I can improve in that area.
Sure.
Thank
Thank you.
We have one, thanks for the session, and one query only which we can answer in the next week.
No, you can ask me now also, no problem. If it is a small one, I can just go ahead and complete it. Otherwise, we can postpone it sometime. Go ahead, no
I'm
problem.
not sure that too early or not. It is just maybe I will just ask. Maybe you can answer. If it's too early or not.
Yeah.
You can decide.
Yeah.
Generally, I have seen your video also. So we saw that the data stored in the block. So, and suppose we have block, we have a file size is 130 and the block size 128. So there will be two block basically, 128 and remaining with 2 MB block.
Yeah. Yeah.
So 126 MB will be used by some other file, correct?
Yes. Yes.
So basically, if we see the data in the data node, each block, either 2 MB or 128 MB, there is a block ID, and this block ID will be stored in the FS image along with the file that this file has this block ID.
Very good question, Deepak. It is not too early. You are asked the right question the right time itself. This question could have been a little earlier. Sorry, even I forgot the point to mention. Let me explain here. I have a file one, which is let's assume that it is 130 MB. Okay. I have a file two, which is just 60 MB. Whatever it is, whatever the size you take. So 130 MB obviously will create two blocks, right? The boundary is 128 MB is the boundary, correct? Block 1 will go to 128 MB boundary. The block 2 will go to that boundary is only 2 MB. Okay. Even this 2 MB we can call a block. Okay, this is also a block. This is the block. Okay. And the 60 MB, see here we're not really wasting the memory. In the memory, this is my memory, the RAM or whatever you take. This is my memory. In this memory, I have occupied from this offset to, or this point to this point 128, from this point to this point 28. The rest I can make use for some other file. From this point it is ended, right? From this point I will make use of for some other, some other this memory I can make use for some other file or some other data. So in this case 60 MB is requires some space. It may make use of block 1 for file 2. It is okay. It can make use that memory for that, the space for that, or it can take anywhere else also. It may be empty, okay, but this space will be make used by someone else. It won't be wasted. Understand, Deepak?
Yeah, yeah, actually, and this is clear, Veera. Suppose like file one,
Okay, file 1.
block
I'll just
one.
write it. You just tell me what needs to be done. File 1, okay.
Okay,
How much size?
the same example. Let's suppose file two. So in suppose file two also the free space is allocated to the file two
Yeah,
in
okay.
the
Allocated, okay.
correct now.
Hmm.
In this case, generally in the fs image file, we have a block ID along with the file that this file has this block ID, correct? So
Yes.
here, suppose file one, the block ID will be suppose B1 and B2. For
F
file two, also the block
F
ID will be B2.
yeah, F1 B1. This is a F1
Yeah,
B2, okay, and F2 B1. Okay, tell me now.
correct. And so in this case, how it will be? It's like it's a duplicacy.
No, there is no duplicacy,
Or
right? So look at here. Let's assume that this block ID, I said B1, okay. So let me put in this. So B101101, and this 2
okay,
MB, this 2 MB will have a block. This ID is 1002 because sequence, okay. And the file
okay.
2, it may start with 2001, or it may start with 1007. It may start with some number. That is a different, right?
Uh, it means for the file three, sorry, file two, still it is using the space for the same space as block two,
No,
but
that
the
is not block.
ID will be
Yeah,
differ.
sorry to stop you, Deepak. That is not block 2. That is not space of block 2. That is the space of your hard disk. That is not space of block 2. That is not reserved for the block 2, right?
Oh,
The
understand it, understand.
the block 2 boundary is only 2 MB.
Mm-hmm. So in physical, in the hard disk, maybe this will be splitted basically, correct? And it will be given a different sequence number,
Correct.
different block ID.
Correct. Yeah, let me show you that as well. This folder structure anyway I'll explain later point of time. Okay, what is the current, what is the BP, and all those things is a block pool. Let's take any of the subdirectory. Look at here. Block 1 blk underscore some number, blk underscore some number, so till here it is sequence block 18, 19, 20. This belong to one file. From it started some other sequence, something else. It won't be a sequence. Clear?
Mm. Yes,
And
clear.
they will maintain the metadata information. What sequence to what sequences belong to file 1, what sequence to what sequences belong to file 2. That will be there.
Mm. Thank you very much, Vijay. Thanks a lot.
Yeah, it's okay. It's my responsibility to answer your question. Thank you. Any other question, guys? I think I'm getting late to some other next session. If you guys have any questions, please go ahead quickly. Else we can end the session today, and we can. I'll let you know when we can meet for the next session. If anyone interested to continue my regular batch, which is 7:30 to 8:30,